This is the solution to the question array of doubled pairs. The goal is to just figure out if a particular array can be broken down in two such parts such that there is a bijective mapping between one part to the other part. Now you can read up more on the question if you are confused what bijective means or what this is, but that is the general question. And you have to return a simple boolean saying it's true or false. Is there a bijective mapping to a particular split of the array? You have to say yes or no to that. Cool. Let's discuss a couple of problems, a couple of sample cases. In the case of 1, 2, 2, 4, can you say that there is a particular way you can break them two apart? Break those 2 points apart? There is. You can have 1, 2 on this side and 2, 4 on this side. So 1 maps to 2 here, and then 2 here maps to 4 here. Pretty simple. What about 4 to 1, 2? The answer is the exact same. See, we don't care about the ordering. The question itself says that we can reorder in whatever way we want. So the first observation, the first core observation says that sort the elements. It's going to make things simpler in the next step onwards. Cool. So once we have sorted, we have things like 1, 2, 2, 4. Now we have to notice the second thing. The second thing is, even though there are two twos, both of them are behaving differently. 1, 2 is mapping onto 1 and 1, 2 is mapping onto 4. Same elements can behave in different ways. Fine, we'll keep that in the back of mind. So now let's start our journey from the element 1 and we'll look at 1 here. Okay, we'll look at 1 here, there is another one, so nothing really yet, and then we find another 2. So this 2 looks at one particular one and says that, okay, both of these can form a valid mapping, and that's good. That's good news for us. So both of these get consumed. Fine, I'm going to use the consume term again. Now what's left is 1, 4. Can you form a mapping between them? No, it's not possible. So this is not a valid case. The answer is false. Okay. What about 1, 1, 2, 2? In this case, each one can point to each 2. It's a simple mapping now, and the answer is true. What about 1, 1, triple 2, and then 4? This case is also valid. Again, same elements are behaving in different ways. There are two 2's pointing to 1 ones and pointing to 2 ones, and then 1 2 pointing to a 4. Now, I want you to count the number of 2's here. 1 here, 2 here, and then 3 here. And corresponding to that, the number of 1's. In case the number of 2's is insufficient to both consume and sort of collide and nullify each other, in case the number of 1's is greater than the number of 2's, this becomes an invalid case. In case they are equal, that's fine. In case they are more, that's even better. Because now you can have 1, 2 more to spare, even though both of these 2's got consumed. You have 1, 2 remaining that can maybe nullify a later element later on. So this is the entire solution basically. Now we're going to make use of a counter basically. Actually, let's just put counter. By the way, the code for and the basic solution is also mentioned here. Good. We have counter and we're going to put the array here. This will basically say, okay, there are 1 1's in the last case, there are 2 1's, there are 3 2's, and there is 1 4. Basically element colon value or element colon quantity. This is going to give us that. Now what do we want? We also want to sort. So we'll sort the count. And what do we check? We'll check if the count of 2 times this value is less than the count of this value. If that is true, well, you have to return false. In all other cases, if they're equal, that's great. If they're more, that's still fine, as we saw here. Cool. Now, we also want to update the counts. So we'll say count 2x minus equals to count of x. At the same time, the count of x is now 0. It's fully consumed. Cool. And now we can just return. What do we return? We'll return true here. Because all of these cases were valid, they sort of nullified each other, and the ending is just, it's good to go. One small thing we need to note is the case of negative values. See, when you sort negative values, in this case it would be -4224. That sort of screws with our ordering concept. We want smaller elements here and larger elements here, and negative sort of just flips everything up. So let's actually reverse flip the flips they do, and we'll have the key as the absolute value. This should fix everything. So it will not actually consider -2 as -2, but actually as 2. It will still be stored as -2 in the values, but the sorting will be done with the absolute of those. Let's do a sanity check now. Okay. Um, there is one more thing, one small little optimization. This count of x equals to 0 is not really needed. Think about why. See, we're already iterating over these counts. So we're starting from the first key in the dictionary to all the way up till the very end. The only thing that we need to ensure is that the next possible key of any of those is correct. We don't care about the already considered ones. You can just have them whatever they want. And so this line is actually not needed. I'm going to submit for a quick sanity check. Cool. Now let's discuss the space-time complexities. This is going to take order of n time and order of n space, because we're going over all the elements one by one, and the counter internally is going to count basically however many quantity of elements there are corresponding to a particular element. Now the sorting will take order of n log n. It's not actually n. In the worst possible case, it could be n, but in the most general case, it would be k log k. Just because the number of elements after we have compressed them into the dictionary may not be the same as number of elements we started out with initially. Think about it. If there are, if it's the 1122 case, there are 4 elements originally in the array, but the sorted array, but the sorted dictionary now only has 2 elements. Only 2 keys, I should say. Cool. So the entire array size could be sort of compressed and shortened. That's why we keep it k log k. This is simple order of one time, and order of one time. Cool, yeah. So this is it for the solution of array of doubled pairs. Cool. Bye bye.